Hello, thank you for the introduction. So, yes, I'm working in A2M's office. Normally I was supposed to make to do the presentation with Sebastian Moreno, but well, he is in San Francisco, so I'll do it myself. We do mainly architecture as normal architect, but also some research and publication sharing is one of our core values. We do, we have, like mainly we are in Brussels, and we have opened since 2 years now an office in New York and another one in Lisbon. And that's quite interesting to be confronted to other ways of thinking, other ways of constructing, and other climates, of course. So the first part of this presentation will be about invisible architecture. I think that we are on the edge of 3 major changes that are happening into the construction world and into architecture world. So the first one is automation. I think Gilles was talking a lot about it. And of course, automation, the 3D printing, the 3D scanning, also the CNC cutting and so on, makes a total difference into how you can work with material and so on. So I think the Zaha Hadid project presented by Arnaud was much more interesting into this automation stuff, but here I will just show you one example. So this is a retrofit in Lisbon. It's an old building, and basically we are redoing the facade and also getting it to a net zero energy building, which is not so difficult in Lisbon climate. So the idea was to use this kind of, you know, this game for children when you play and you push your hand and then it appears on the negative appears. So we did that with the skyline of Lisbon. Ta-da! And so we just have drawn those lines of the 7 hills of Lisbon and transform it into a pattern that will be cladding the building. And so normally it's way more fluent in my computer, so you can stand on that and it's kind of hypnotic, no? And here the design, the idea was to go from the drawing on paper and to get it to just like 5 or 4 different elements that will be next assembled into the facade to make this design on this retrofitting building. And of course, it has impact on solar lighting, on overheating on this building in Lisbon and so on. For each project, at first I was thinking about not showing any virtual image or visual thing, just having the kind of technical drawings and animations. But, well, you know, I know that in architecture still we are very obsessed with visual impression of building and virtual 3D. So the other major change that is happening now in the world, and that has a very deep influence, I think, on constructed world, on where we live, is the digitalization. So for a long time we did buildings that were office building or a residential building or just like a building that had a function. But right now, when you look at, well, if you have a Wi-Fi connection, basically you're able to do whatever you want just in a small cube of 6 spaces. You could work from there, you can do your shopping, you can do whatever you want. So there is kind of a shift on the programming and of the buildings, and it's also happening with digital things that have consequences on the real world. So for example, Amazon has always changed the way we shop, we go to retail and so on. There are lots of malls that are closing in America. That's maybe a great thing, I don't know. Airbnb, how many rooms have Airbnb? 0. They have no rooms. They are the biggest hospitality chain in the world. We've talked also, I don't remember who was talking about all the MOOCs that were also for education and office. You know, there is the WeWork now is in Manhattan. WeWork has taken off like the main places of office. They are the biggest office space in New York. And it's the same with Uber, 0 taxi. They have no taxi. It's just so all those can be just seems that it's digitalization. It doesn't really concern architecture, apart that it has an impact on the real world, shop closing, changing of function and so on. And maybe at some point there will be an Airbnb of the architecture. We don't know. Maybe it's architecture. So as architects, we are continuing to assume that when we do, for example, a residential building, we have this like a stereotype of a family with the father, the mother, and the children, and we continue to draw, for example, kind of those plans with the room that is the bedroom and so on. But the models are totally changing, and also people were able at some point to buy a house in the middle of a loan, you know, and there was their house, they were having a loan for 25 years, and they were building into this living, like it's the suburban, you know, the US suburban typical house in the middle of the prairie. And now it has totally changed, because actually your needs are changing, the family is changing also, and so we can't like have some settled place for 25 years. So it's also a change between what is public and what is private. So not only with internet and so on, but also with shared space and co-working space, co-housing space. So there are new ways of inhabiting the world that are appearing just with those kind of digitalization. So this is all that you are going to see as animation. You know, modernists were saying, Louis Sullivan was saying, form follows function. Well, and then the postmodernists were saying function follows form. And with those change of functions and form, well, where are we going to? We have to like put this in question. So this is another project. It's development in Luxembourg. And that was quite interesting. So what I was going to say, it's all the rhino, grasshopper animation and so on are made by Antoine, that is just standing there. He's our grasshopper guy. And I can't do that, I just show it. So this was quite interesting, because there we had 140,000 meters square of building to build, and with different function, of course, and mostly residential. And we were trying like to shape this new neighborhood, not only, so here it's very nice because, you know, it's a transition of those identical square meter, but in different shapes and forms. But it's also, it can be linked to different parameters that are not always seen. For example, the sunshine, so daylight into the public spaces. So we can change all those forms. So here we had made like several iterations, and what is interesting with rhino and grasshopper actually, it's so this line of formulas, and that's not, you know, you can have a tool that's not because you have the tool that you're going to do good architecture or not. And I think where architects need to also provide creativity is in those things, those formula, in what parameters are you, what algorithm do you want to put in place to achieve those numbers that are there. So it's in between some, well, some image, you know, still visualization. And the last shift, it's more about virtualization. So I have a question for you now. In architecture field, what is the most disregarded material? Go on, don't be shy. Concrete? Somebody, okay, I'm gonna help you a little. It weighed about 1.2 kilo per cubic meter. Okay, 1 over. It can constitute 99% of a building. I would say even 99.99. And good. So, and it's free for no.
C'est pas nouveau, c'est Corbusier qui l'a dit.
Que c'est
C'est Corbusier qui l'a dit.
So, I just steal it, so it's true. It's, but what didn't exist at Corbusier time was that air was still invisible, untouchable. You didn't have any tools to really design it. And so that's what is changing also with all those tools, is that now you actually could design a building just by designing the air and then putting some algorithm that gets what material is going to be around it. So when we think about architecture, well, basically what we do as architects is allowing human activities to take place in a comfortable environment. So it means that even if it's raining or cold or the uncontrollable exterior weather has to be stuck to an interior conditional area volume. And so this atmosphere that we create here this space that is conditioned with certain temperature, certain light, certain airspeed, also humidity, and so on. So that's a material. So that's with this that we wanted to work on. So oh, sorry, that's Sebastian's part. I can't do that. I'm sorry. No. Okay. So we decided as architects also that if we are going to build some shape and to isolate certain volume of space to be comfortable, that we have to do it in an intelligent way. It means that we have to use material and shape and insulation and whatsoever that can allow very less energy, mechanical energy, but to get to some point where it's comfortable. So we use tools. Oh, no. Still not that tools, huh? We have learned a lot about different tools today, and I think, well, of course, Excel, mother of all, and the PHPP that allows also us to calculate exactly the need of energy to keep a space, to keep your volume in comfortable. We use also all those kind of different tools. And so those are the ones that are revealing this air and that allow us to really conceive a building that is comfortable but with air. There is also like the daylight visualizer. I don't know if the sponsor is still there. Well, free advertisement. So with those elements, there are things that we don't see that suddenly appear. It can be light, it can be energy with thermal bridge analysis and so on. It can be daylight on the public space and so on. And so with those tools, we have tried to create something new. I don't know if you're gonna, as class suggested, just do another type of architecture, but I think that we are just on the path to do that. So this was also another little project. We just play around with that. It was just actually to have fun, but we played with the structure and also the opening. It's a patio that is between two buildings, and so the structure was kind of curved, and also we have an opening, and we wanted to have the maximum sunlight in between these two buildings, and so we analyzed exactly how much solar radiation was arriving on the building, and so we could have the best ratio into that. So nice image, huh? Ha, visual. Okay, so we've seen that. So what common dimension is present in energy modeling or daylight analysis or in virtual reality? It's unstoppable. One can't buy it.
Time.
It's known as the fourth dimension. Time, perfect. So exactly, this is the other transforming thing with all those tools is that for a long time we were drawing in 2D when we had 3D, perfect, and now we have added a new dimension that is time, and so it allows us to also maybe when you can add time, you can also allow like a linear thinking, like from the construction of the building to the destruction of the building. You can have also an annual thinking, like a cycle of energy consumption for 1 year, or the solar energy or so. So finally what we thought is that actually form doesn't follow form anymore. And when you add time to this, finally what we see is form and function follow flow. It can be airflow, it can be energy flow, it can be flow of people, activities, and so it's the thing we have tried to do in our architecture, and that's where it comes to constructed atmosphere. So what we want to do is using material, physical reality of building insulation and so on to create different type of atmosphere, and those atmosphere, as much as the visualizer was showing with natural light and how much the space can be lightened or not with a Velux. I'm not for Velux, but well, we use it all, and it's free. So what we wanted to do here was, instead of using the traditional process of the architect drawing something and then giving the baby to the engineer that was putting all the patches to make it warm enough with central heating, to have enough light with electrical light, air conditioning, and to make it work actually, we want to start at the very beginning of the process and just know what is the effect of any material that we are putting in process in construction. So regarding energy, of course, we begin to think about different ways of approaching it. You know, many people, many architects consider the EPB legislation as a constraint, as a burden. Oh, we have more things to comply with. We were thinking, well, maybe sustainable can be high design. Maybe we can be inspired for building with just energy. So this building, it was so it's an hotel, and there we wanted to have a facade that is a volume, so that does exist really. And so there we have also do it in Rhino and Grasshopper, and it's very subtle, but you can see it, no? We have moved all the edges so that there was some kind of well, here it seems that it really won't move in reality, but with the insulation we have made a form that is that allows enough energy to stay inside of the building and not too much outside, but also that gives a form. And that's at the end the result of it. But with those tools we could exactly compare how much energy is going out and in of the building. Because you know, if you remember this little bubble, if you create a conditioned space, then it won't be, when it's warm outside and warm inside, well, nothing happens. But when there is a difference between inside and outside, when it's cold outside, warm inside, there is a kind of a shift, because nature's always wanted to have some balance between inside and outside, no? And so there is a kind of flow going from inside a building to outside a building. Using insulation can allow us to master this flow and prevent it from happening when we are in a cold climate. So, so this project was about, well, I had to skip a lot of projects, and I'm in the last presenter, so I won't show all of them. But most of the projects that we do now are also very much into the light process. And so we thought, okay, can natural light shape a building? Well, of course not. You still have to have an architect there that is drawing something, but we can really play with the natural light. So this is just an example of a project for CityDev, and there we analyze the form of the building to make sure that in every place, every public space, every outdoor space, there was at least 2 hours of sunshine during the day. So those are again images. On another project, we took it a little bit further. So this is a video, so I'm not sure the computer will handle it. So we had a form that was quite defined. Oh yes, it's working. No, yes. So we analyzed exactly how much solar radiation was coming on each face of the building. It was an office building, so mainly what is difficult in office building is to avoid overheating. You want natural light into the office, but you don't want to have it overheating and to have too much heat so you don't have to put air conditioning. So we made a simple rule that is very simple here. Antoine can explain it to you later. That is just putting, you see on the facade, we have vertical elements, and we wanted to have them closer when there was more sun into the facade, and with a larger, wider distance when it was on basically north and south facade. But so what's interesting there is that the design is not just made by the architect that decided something, it's made by some rule that we have found there. So at the end, it gave those type of facade, and so you can see when there is like nearly no radiation, the distance between two elements is very wide, and when it's on the south facade, it's really closer. So it's using architectural elements that are static, that don't move, material, to create an indoor climate that is comfortable. And so that's, here you can see the design. Also, what we like about those tools is that it allows also to make the verification that you have enough daylight into the volume. So we use different variables, different type of program, and so there is a daylight factor which allows daylight analysis, and we use also daylight autonomy to see how much we can save with natural light opposed to electrical light. Well, it's interesting to see that. And so, for the very last project that I presented today, I'm going to talk more about flow. So there are also in architecture some kind of material flow from construction to the deconstruction to the end of the building, and during all the time of the living of the building. So one of the questions we ask ourselves is, can we regenerate the environment? So can we, with a building, make something that is better than if the building wasn't built? So on this project, we developed kind of a concept that is that we call perma-city. It's from the permaculture. And so, of course, the first thing was to get to at least a passive house building, so a building that needs very, very low energy to maintain a comfort inside. So with only architectural elements, we are able to ensure a comfortable indoor climate. So, of course, this is reducing first the energy that is consumed by the building. And then, as soon as you have diminished the quantity of energies to the lowest point, then it's very easy to compensate with all the renewable technology and so on. We made also some projects that are completely off the grid, that is more in the idea of resiliency, of being able to have this building maintaining itself without any outsourced energy. And then the next step is, of course, thinking about material and the embodied energy of all the material, and to take it in account. So it's basically the building and the construction of the building. And so energy is like the biggest part of the cake. And then at the end, the regen project, you can add in, once you have made all the things that is really important, so on energy side, you can go with the cherries on the cake, so some water saving, waste management, biodiversity, and so on. So on this project, you can download the document there. The idea was really like to create this kind of forest system where every element is producing and consuming, and then it's going into a cycle. So it's not anymore a linear production of building. It's really like the idea is to have all the time a cycle, a circular design. So on this project, we of course the first part was to make it livable, because we don't live in an Excel sheet. So the idea was to make sure that we had enough sunlight into the outside part. And well, there was a lot going on to this. Even the parking lots were created with lifting of this kind of slope. So it was, of course, all pedestrian, and because we think that at some point the car won't be the permanent way of transportation, we had also foreseen that this can be like you do just some opening and the parking can become something else, and it's more flexible. And it was also, because it's next to the Seine, it was also able to be floated if, I don't know, if level rises. So this was the project we made in Paris, and actually it was not changing. There was already this amazing skyline of Paris, and then just we added this project, which was just regenerated. So actually, I won't go into detail of all the process, but basically we were comparing the consumption with CO2 equivalent. So on a normal project, you have like the consumption of the building and then all the embodied energy. So the first step was to reduce this consumption of energy, and then going with some different level of captation or production for CO2. So solar panel, green places, also work on mobility, biomethanization, and photocatalytic coating. So at the end, the balance was equivalent to 0. But so at some point we were thinking, okay, what is 3017 equivalent CO2 per year? What is it exactly? And we made some research, and it corresponds to approximately 1,480 acres of forest. Okay, that doesn't say anything to me, neither, no? So what are those acres of forest? Well, actually, this project was next to the Seine here, and we have made a research, and all the park and garden of Paris are making 1,360 acres. So basically, on doing this project there, that was behaving like a forest nearly, we constructed the equivalent of all Paris acres. So what we did with this project was actually that. And that's it.